guys, this is Professor Janacek. I want to take a look at increasing, decreasing, and concavity of functions with respect to the derivatives. Let's start with this first example where I have f of x. First thing I want to make sure you recall from algebra is that if our function is increasing, then the slope is positive, and if a function is decreasing, that means the slope would be negative. All right, so looking here, if I look at this interval from negative infinity to negative 2, we see that our function here is decreasing. So that means the slope is negative. In fact, you can actually calculate that slope. Given those points, our slope is -1. If we look at the interval from -2 to 0, we can calculate our slope just in this little section here. The slope there is actually going to be a positive, and specifically it's +1. Again, slope, rise over run, we go down 1 over 1, down 1 over 1, that's a slope of -1, or up 1 over 1, up 1 over 1, our slope is +1. And then finally, if we look at the interval from 0 to infinity, the slope there, let's see, we go down 1 over 2, so our slope here is -1/2. So what does that look like on the derivative, the graph of the derivative on f prime? Well, this tells us, remember, the slope is, the derivative is the slope of the tangent line. So let's see, that tells us that on this interval from negative infinity to -2, our y value is -1. And from -2 to 0, the y value is +1. And finally, from 0 to infinity, the y value is -1/2. So according to our graph, from negative infinity to -2, our y value is -1. Would give us something like that. Oop, wait, -1, not +1, down here. There it is. From -2 to 0, on that interval from -2 to 0, we have +1. And then from 0 to infinity, we have -1/2. So here we have -1/2. So that gives you a little bit of an idea of what's going on with the derivative compared to the function. Let's look at one that's a little more complicated. Let's take a look at g of x. There we go, nice little roller coaster of a function. Another thing I want to point out is that I've already kind of identified the intervals here at the bottom. Now this is probably more information than we need, but that's going to kind of help us figure out what's going on g of x, and we can interpret that into g prime and g double prime. I've also made note of the x values in between each of those, again, just so that we can easily reference them. All right, so let's take a look at what's going on for each interval. So first thing, looking at, again, I'm just going to take a look at the slope on g. So on the interval from negative infinity to -4, so that's just this little bit, my slope is negative. And I also noticed that from -4 to -3, it's also negative. So it's, it's positive. My function is increasing that entire time. So the interval there is increasing, which tells me my slope is positive. It's positive slope, positive slope. Now, from the interval from -3 3 to negative 2, as well as from negative 2 to negative 1, these two intervals here, my function is decreasing, which tells me that I have a negative slope. So the slope now is negative. Okay, from negative 1 to 0, and then from 0 to 1, my function now changes to increasing, which tells me that the slope would be positive in the next two intervals. My slope is positive. And then let's see, on the intervals from 1 to 2 and from 2 to 3, it goes back to decreasing. So that means the slope would be negative. Negative slope for each of those. And then finally, from 3 to 4 and from 4 to infinity, my function is increasing, so now we have positive slope on those last two little intervals. What I'm really interested now with is when that slope is actually equal to 0. So you'll notice that it changes from a negative to a positive, which tells me that my slope would be 0. That also happens, so the slope is 0 here, the slope is going to be 0 here, here, and here. So what does this tell me about G prime? G prime then, anytime my slope is negative, my slope is positive on G, that's telling me that the y value on G prime is positive. The y value is positive, then the changes to negative and negative, back to positive and positive, back to negative and negative, and then one more time back to a positive and a positive. So again, this is telling me what's going on with the y values. Again, I'm really interested though when that changes. So here it changes, so that means it must be equal to 0 between those two intervals. Here again it changes from negative to positive, so that's got to be 0. It changes from positive to negative, that tells me it's going to be 0. And then when it changes back from negative to positive, again, that's 0. Okay, so now I have some points. When x is negative 3, I have the point 0. I have the y value of 0. When x is negative 1, my y value is 0. When x is positive 1, the y value is 0. And when x is positive 3, I have the y value 0. So that gives me 4 points that I can put on G prime. So we have the point negative 3, 0, negative 1, 0, positive 1, 0, and positive 3, 0. Just so happens that these intercepts are symmetric, but that's not necessarily going to tell me that my graph is symmetric. All right, so what happens in between those points? Well, to the left, from negative infinity up to negative 3, my y value is positive. Well, positive y value means it's going to go up. Something like that. Between negative 3 and negative 1, right, those two intervals, my y value is negative. So the y value stays negative here. Oops. I'm back to positive, back here to positive. On the next interval, from negative 1 all the way up to positive 1, I stay positive. And then on the next interval, it goes back down to negative. Now notice it might not always change, it just so happens that these are changing signs. So this one's negative again. And then here at the end, those last two intervals, from 3 to infinity, my y value will have to be positive. Oh, and looks like one of those was written incorrectly. Let's fix that. There we go. Those y values are both positive out there, which tells me I've got something like that. All right, so there's a quick sketch of G prime. Now let's see if we can take this and look at what happens with G double prime. Okay, so for this one, let's see. Again, I'm going to just go through each individual interval. So here we have, looking at G prime on the interval from -4 to infinity. Oh, that would actually be way out here. Way out here. That interval along with the next interval all the way up to -3, my function is decreasing. So that means the slope is negative. So the slope is negative from -infinity to -4, from -4 to -3. And look at that, even on over here, that little interval all the way up to this point here, we have a slope that is negative. It is decreasing. But then notice what happens from -2 all the way up to 0. Now my function is increasing. So the next two intervals, the slope is increasing. So we've got a positive slope. Or my function is increasing, so we have a positive slope. Notice, and that goes all the way up until this point here. And then let's see, it's going to decrease from 0 to 1, and then from 1 to 2. So it stops decreasing down here. So the next two intervals, my slope is negative. It is now decreasing. And then it ends up that the final, actually 3 intervals, my function remains increasing. So these last 3 intervals, we have a positive slope. All right, so what happens to the second derivative here? Well, this tells me that my y values follow the slope from G prime. Again, the y values on G double prime follow the slope of the y values, of the slopes on G prime. And now I just want to see, when do these change? So I have negative, 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 oh, and there's a positive. So that's what it's going to change, and the y value will be 0. Next we have positive, positive, oh, there's change. And so we have a y value that is 0. Negative, negative, and then it changes. So now the y value is 0. And from there on out, positive, positive. Now we'll use those positives and negatives here in a second, but let's go ahead and write those points. At -2 on the G double prime graph, y is 0. At 0, y is 0. And at 2, we have y is 0 on that second derivative graph. So -2, 0, and positive 2. Now let's take a look at what happens to the left of that first point, that leftmost point. It all stays negative. So my y values now are negative. Between the leftmost point and that center point, the y values are positive. So I have positives. Then between the next two intervals, it's going to now be negative. And then there at the end, the last 3 intervals there, it's all stays positive. My y values are now positive. Actually, let's do a little better job with that. And then we have positive. All right, so now let's compare these graphs. Let's take a look at what's going on. So notice every time I have an intercept here, I have what happens on my G graph. So when G prime is 0, notice that G of x is either a maximum or a minimum. So moral of the story, we notice, of course, that if G prime of x equals 0, then G has an extrema. Either a maximum or a minimum. Also in between those, if, oh, those are F's. If G prime is equal to 0, then G has an extrema. If G prime is negative, then remember G decreases. And if the first derivative is positive, then my function is increasing. So again, positive, it's positive means it's increasing. If it's negative, that means I'm decreasing. All right, let's also compare the second derivative with our function. So notice every time I have a 0 on the second derivative, what happens to G? Well, let's take a look at those. What's going on there? Well, it turns out it's changing concavity. Notice here it's concave up, and then it changes to concave down. So again, concave down here, concave up here. So what happens when the second derivative is equal to 0 is it changes concavity. We actually call that a point of inflection. So if G double prime of x is equal to 0, then G has what's called a point of inflection. And now let's talk about the concavity. So notice when G double prime is negative, G is concave down. So notice it's concave down for the entire time that G prime is negative. I'm sorry, G double prime is negative, then G is concave down. And if G double prime is positive, notice what happens. We're looking at concave up, back on G. So there we go. If the first derivative is 0, we have an extrema. And if the second derivative is 0, we have a point of inflection. If the first derivative is negative, then the function is decreasing. If the first derivative is positive, then we have increasing. If the second derivative is negative, then we have concave down. And if the second derivative is positive, we have concave up. Well, there you go. Enjoy.